HTML, CSS and XML. Aims and objectives then for this session are to understand the nature of the web and markup languages, to be able to write web pages using HTML, to understand how CSS styles work. These allow you to modify what a web page looks like, be able to write a CSS style for an HTML page, understand the relationship between HTML and XML, and gain an overview of problems with the web and some of the proposed future directions. Part 1. Markup languages. So a markup language is simply plain text containing markup. What do I mean by markup? Well, it's simple, again, plain text labels, but introduced by some special character, which might be a less than sign, a greater than sign, a backslash, a percent, a square bracket, and so on. And examples include HTML, XML, and LaTeX, which is a language used for marking up documents to be able to produce publication quality printouts of documents. So we're going to start with XML because that's kind of basis of what we're trying to look at. XML stands for Extensible Markup Language, and as I said, it uses simple text markup to indicate what's in the file, and it simply marks up the content to describe its semantics, so what the following piece of data means. So it's a little bit like a simple version of a database. We can have entries and we can describe the data that are in those entries. And with XML, we're completely unrestricted. We can invent tags which identify the content in whatever way we wish. So here's an example. This is some XML that we've used for describing mutations present in PDB files. So the whole thing is wrapped in a mutants tag. So this is the tag. It's introduced by a less than and closed by a greater than sign. So this means we're beginning a section which is describing mutants, and then the version with a slash before it means that we're ending the section. And then within that, in this particular case, we have one mutant group, and that's ended here. And within this mutant group tag, we have what's called an attribute, where we're saying that the native structure, so the normal sequence, the unmutated sequence, is this particular PDB code, and this is a domain number. Then we're describing this mutant group, or in fact the native entry within it, using a structure tag. So we're opening it here, closing it here, and within that we have a method, a resolution, and an R factor. So these are measures of quality of the crystal structure. And then we have the mutants. So we have a mutant with a domain identifier of 2BCD01, information about the structure just as we had here, and then information about what the mutation is. In this case it's residue L24 is mutated from the alanine to an arginine. And similarly here 3CDE01, information about the structure, mutated at the same position from an alanine to a histidine. Now XML is a strict language. It's case sensitive. Every opening tag must have a closing tag. Tags must be correctly nested. Attributes must always have associated values, and the attribute values must always be in inverted commas. What do I mean by correct nesting? Well, this gives you an example. If we have tag A being opened and then tag B being opened and then some data, we must close tag B before we close tag A. So this would be incorrect where we're opening A, opening B, then closing A and closing B. XML tells you nothing about how data should be presented. It's purely used for markup of the semantics of the data that it contains. And while it is sometimes used for data that are going to be presented on a screen, it's often used for data that are not going to be presented. So many programs use XML to store configuration data, and large data sets such as Interpro, dbSNP, and the Protein Data Bank are now distributed in XML. What about advantages and disadvantages? Well, the pros are that the format is quite simple. A lot of people are familiar with HTML, so the style, as we'll see later, is quite similar, so it tends to be fairly familiar to people. It's quite straightforward to parse, and there are many parsers available to allow you to do that. But the disadvantages are file size bloat. That means that we have a lot of tags and markup for the amount of data that we have. That said, the files do compress very well. The format is perhaps too flexible, and we will come back to why that's a problem in just a moment. And of course, while the point of XML is to mark up the semantics, the meaning of the data that are contained, those semantics need to be defined very carefully. For example, what is a gene? Is it just an open reading frame, or does it include upstream regulatory regions? So just coming back to this problem of format flexibility, if you ask one person to design an XML format to describe a particular thing, and you ask another person, they will probably come up with different ways of doing it. So it's not a problem per se, but it's something that you need to be aware of. So in my mutations example, to describe each mutation, I said mutation residue equals native equals and substitution equals. So this was all done with attributes. But equally, I could have done this. I could have opened a mutation tag, and that could have contained a residue tag, a native tag, a substitution tag, and so on. Now, a data type definition is something that allows you to describe which of those ways of doing things is allowed for a particular document. Now, I'm not going to go into this at all, but there are two conflicting standards. One is called XML DTD. This is the original standard and still very widely used. And the other one is called XML Schema. This is a newer standard. It's more flexible, and the description of the allowed nesting and allowed attributes and so on is itself done in XML. Now, there are a lot of other technologies associated with XML, one of which is called XSLT, and this stands for Extensible Style Sheet Language Transformations. Now, this is effectively a specialist programming language where the code itself is written in XML. It takes XML as input, and as output it can produce XML or HTML or plain text, and that really allows you to do anything. For example, generate SQL as output. So this can be used to convert between XML formats or to generate reports in HTML. So we actually use this for a resource that we have online of antibody structure information. So there are now several thousand structures of antibodies in the Protein Data Bank, and we maintain this resource which extracts information about those structures and then displays it on a web page. So the way that we do this is to generate an XML file for each of the PDB files. We then concatenate those together into one big file, and then we use XSLT to extract the required information as a report in HTML. Now, XSLT is actually part of a bigger language known as XSL, or Extensible Style Sheet Language. And this is a full style sheeting language for XML, and it describes how the data should be presented. In practice, this isn't very widely used still. Rather, people tend to convert to HTML and then display HTML pages. We're going to take a short break at that point, and in part 2 we're going to start to look at the web itself and HTML.